So again, we want to, first of all, measure these pieces out. And just like you saw before, only pick out the bigger pieces. We don't want to be fracturing something that's really, really small. So measure area per piece, piece attribute, it's called name. Great. Now we're going to use a split, and we'll say if the area is greater than 0.5, then go ahead and use that left input. Now just to see what we're doing, make sure that this is what we want. Take a color. This is green. On the other side, we're going to do red. Two colors, merge them together. Let's see what that does once we plug it in right here. Okay, that's beautiful. The next thing to do is to create a box. And that might be confusing at first because this box is not the same thing as a grid. We want to turn on the single pass. Say we have a piece like that. With this top input, we can go ahead and just take that box and situate it over it like that, which is pretty sweet because now we can just get rid of these faces. Well, hold up now. I think I had select by group on or something. S for select. Let's turn off that group selection. There we go. Now we have just the grid. We can subdivide that a bunch of times, maybe like 5 times. Well, less than that actually. Let's say 3. Use a mountain sop, turn it up, and if we template our piece, here's where we're at. Now, the next thing to do is to try to get this in the center of the piece. We also need to randomly rotate this plane, so it's actually best just to copy this to some points. That would be the most straightforward way of doing it, in my opinion. So let's do this. Create a sphere, and we're going to take the bounds of our large pieces again. This time, though, we're going to shrink that down and create a little zone where we can scatter some points. So if we do that, take the transform. If we try to scale this, it's going to go right towards the origin. And so to change this pivot right here, we need to, first of all, create a spare inputs because eventually we need to compile this. Bring over that sphere. And then under the pivot transform, pivot translates, we're going to use the centroid expression. We'll say -1 means grab that extra spare input we just made. And also you need d_x for the x, Control C to copy paste. There's the y, and there's the z. So now we go to scale this thing, good to go. We'll take a uniform scale of, let's say, 0.2. I found that having a little bit of variation is just nice when doing it the sphere way, because from here we can scatter and we can control how many planes we want via this scatter sop. For the force total count, we'll say 1 for right now. In the future, we'll change that, but just to get things started, we'll say 1 on that. Copy the points. Also, we want to randomize those normals, so we'll use a attribute randomize on the points, attribute name, and for normal, inside sphere, copy the points. And at first, nothing happens. Well, actually, yeah, we have a grid. It's way out there, though. And that's because we need to get this grid at the origin so that when it goes to copy, it doesn't copy over that transform with it. Easy enough, though. There's a cool trick where we can just pack this grid, basically turn it into a point. Then we can use a point wrangle to take that point, put it at the origin. So your position points is at 0, 0, 0, like so. And then, of course, unpack it because we still have to do stuff with that grid. Now we can go to the scatter and we can right-click this force total count, reference scene data. This might freeze up because I have auto update on. That's been a bug lately. Sometimes, yeah, when you try to scroll this down, it'll get stuck evaluating Python. Nothing works. You hit escape. Sometimes it goes through. Okay, this is a bug. Again, 18.5351. But to fix that, simply go to manual, and it's going to be smooth as butter. There we go. Attributes, global, iteration. That's what I want. This is now going to be Alt-E, a seed for the random function. So that's a value between 0 and 1. So fit a value, which is 0 and 1, between 0 and a maximum of 4 planes. Apply, accept, and just to double check that this is working, click the name text right there and just go through a few frames here with this highlighted. And now back with auto update. So now this force total counts. Let's see, 3, 1, 4, 0. Looks like we are getting the whole range in there just fine. Okay, so we do that and we want a Boolean. That's the whole point, right? So Boolean, let's do a shatter. Let's say pieces of B. We have the large pieces that I will put over here in B. So again, that's what we're shattering. It's point of, pieces of B. There we go. There's A. We'll go like that. And now, I believe this is all we need. With A, though, this is a surface. Keep that in mind. Let's just see what happens when we do that. Also, let's throw on a compiled block. Again, back to manual as we do this. This guy goes all the way up here. And I believe that is all we need to do. So let's see what happens when we then create a temporary assemble SOP, exploded view, and we let this kick. Oh, also, for each, uncheck single pass, check on multi-thread. There we go. And after doing that, we end up with some problems. Go figure. Well, here's the deal. Whenever you come across this is something you'll come across at some point or another. There is a way around this. And so let me tell you about that. To make a long story short, we middle mouse this, we have this error which says crossed boundary of unshared edges. And so basically this is having a hard time figuring out how to fracture this because of the way that we've defined this solid and surface. Now, the deal is that set A is a surface. It's not something with volume. So that's set correctly, as well as the solid in set B. And, if something wasn't a solid or a surface, that would cause this sort of thing to happen. We could try going up here and creating a fuse, but we actually already did that right here to see if we can fix any sort of unclosed polygons, right? But there's actually a better way of doing this because the fuse can be a very dangerous node in general. So here's what you can do. Instead of saying surface and solid, set both of them to surface. Now, that's going to create a problem at first. And let me just turn on single pass so that we can see this a bit better. We go ahead, we do the Boolean. We end up with these pieces, but they don't have an interior. See how it's just thin like that? So now we're going to create a loop within a loop. Going kind of crazy here, but we need a connectivity SOP to start, and we'll use for each connected piece. So we'll go through each one of these connected pieces. We'll use a polyfill like that. So say we do a polyfill, it's going to freak out a little bit because we have quads going on. Set that to triangle. Now when we look at these pieces, as you can see, we've filled the interiors like so. It's a much cleaner way to actually fracture because it prevents that issue from happening. Also, while we're here, let's use a divide SOP so that we try to somewhat connect all these things into triangles. And yeah, let's see what that looks like on all the pieces now. Okay, and there you have it. Now we have all of our pieces. They're right here. There's a lot of them, honestly, but we don't have any more of those weird artifacts happening. So that's that. In the next video, we'll move on.